Okay. See, good morning, all of you. Yesterday class, I have given modern periodic table. That is nothing but long form of the periodic table. So there I have given the periodic table elements are classified like as a groups and periods. Vertical columns are called groups, horizontal rows are known as periods. There are 18 groups are there, 7 periods are there. So I have given complete explanation. Now, the IUPAC nomenclature for elements having IUPAC nomenclature for elements having greater than 100 atomic numbers, more than 100, more than 100 atomic number. See, so elements having more than 100 atomic numbers, that elements IUPAC nomenclature. Generally, so more than 100 atomic number elements are highly unstable. Highly unstable and are obtained in minute quantities. Minute, very less quantities. At the same time, this has led to several complications in deciding the claim of name of the element. So atomic number more than 100 elements. These are generally highly unstable. These are discovered very minute quantities. So here several complications are there to deciding the name of that element, because okay, different scientists, they are discovered, they are given separate names. For example, atomic number 104 is there, was discovered by both scientists, Rutherfordian and Soviet. Atomic number 104, that is discovered by two scientists, Rutherfordian and Soviet. Rutherfordian, the name is given, that is called Rutherfordian. So at the same time, so Soviet, the name is given, that is Kurchotivium. See, same element, atomic number 104. The element was discovered by both American scientists as well as Soviet scientists. Okay, here American scientist name is given Rutherfordian, and Soviet scientist the name is given Kurchotivium. Because of that reason, here it is somewhat complicated. So, which is the correct name? So, up to that, so they are given without complication, confusion, more than 100 elements having one particular names are given. They are introduced some rules. So, up to we are getting correct name. Up to that, they are given any element having fixed name. IUPAC nomenclature rules are given. Okay, whatever that. So how many scientists they are find out, that is not important. Up to confirmation, they are given up to that some fixed IUPAC rules are given. Okay, what are the rules? For example, according to the rules, if digit 0 is there, IUPAC Latin word, they are given it is a nil. Nil. Their name is given nil. Latin word nil. Nil means 0. Nil. At the same time, the nil word, simply you can say shortcut N. First letter, abbreviated. Just first letter N means nil. Like that, if digit 1 is there, it is referred as a unreferred one. This is word, just we can say U. If 2 is there, that is referred by. So first letter B. B is there, that is referred by. If 3 is there, that is tried. First letter T. If 4 is there, that is quad. Quad. First letter Q. Quad. 5 is there, pent. What about the first letter P? 6 is there, hex. First letter H. 7 is there. What about that? 7. Sept. Sept. S-E-P-T. Sept. S. Sept. Not hept. That is sept. If we can take hept, already here H is covered. That way they are taken sept. 8 is there. Oct. O. Oct. 9 is there. N. E-N-N. First letter E. Based on that, they are given names. Okay, at the same time, they are given rules also given. After these letters, we are added a common letter I-U-M-U-M. For example, say if I have taken atomic number 101. So we want this atomic number name. Okay, followed by symbol. We want the symbol. Now, say for this atomic number 101, what we can say, first one means unknown, UN unknown. Complete name un. Next 0. What about that? Nil. Next 1. What about that? Un. Commonly by adding for all IUM. IUM is the common. Un, nil, un-UM. Un, nil, un, IUM. Common that is. That is the IUPAC nomenclature. Okay, say atomic number 102. Un, nil, un, 1, 0, nil. 2 means by. What is the common here? IUM. Un, nil, by, IUM. Un, nil, by, IUM. Say 103. What is the name? 103.
Nil trium.
Very good.
Nil trium.
Nil trium. Very good. Say 104.
Nil condium.
Very good. Nil wadium. IUM. Okay, 105.
Nil pentium.
Nil pentium. Okay, say 106.
Nil hexium.
Nil hex IUM. EM. Okay, 107.
Nil septium.
Very good. Nil septium. 108.
Nil octium.
Nil octium. Good. 109.
Nil lenium.
Nil Anium.
Anium.
110.
Anil. Anil.
Un,
An
un,
anil
Anilium. Okay, 111.
An.
an
Anium.
Ium.
Anium.
112.
Biome.
Bium. Okay, and so on. If we can take 118, say that.
Octium.
octium
Octium. It is the IUPAC name. Okay, now its symbol. Shortcut form, if we can take its symbol, see. Symbols we are represented first letter only. One first letter un may U. Zero. Zero first letter, what about that? Nil. One first letter, what about that? An. Three symbols. An, nil, an. This is equals to 101. 101. Like let's say 102 symbol.
UNB.
Very good. UNB. Say 103 symbol.
UNT.
Very
UNT
good. UNT. 104 symbol.
UNQ. UNQ.
UNQ. 105 symbol.
UNP.
UNP. 106 symbol.
UNH.
Very good. UNH. 107 symbol.
UNS.
UNS. 108 symbol.
UNO.
UNO. 109 symbol.
UNE.
UNE. 1010 symbol.
UNN.
UNO. Say that 110.
UUN.
Very good. UUN. 111.
UUU.
U.
U.
112.
UUB.
UB. And 118.
UUO.
O. Bus.
O.
These are the shortcut symbol. If anywhere, if they are given 108, what is the symbol? What we can take? UNO. That is the 108 symbol. Okay, now after that, this is the IUPAC nomenclature they are given. After that, they are identified official name. IUPAC official. Okay, they are identified official name. Okay, after that they are given official name, symbol also given. Okay, first they are given these names. After that, they are given some elements official names. 101. That is called Mendelevium. What they are given name? Mendelevium. So Mendelevium element means 101. Symbol MD. Mendelevium. 101. Like that, Nobelium.
Nobelium.
Nobelium. What is the symbol? NO.
NO.
Like that, the important one more, 103, Lawrencium. See this, Lawrencium. So, what is the symbol here, Lawrencium?
LR.
Very good. LR. It is one important, Nobelium and Mendelium. These three important, first three. Okay, next one. What about that? 104.
Rutherford.
Very good.
Rutherfordium.
Rutherfordium. What is the symbol here, Rutherfordium? RF.
RF.
It is also one of the important. 105. What about the
Dubnium.
Dubnium. What is the symbol?
DB.
Very good. DB. Next 106.
Seaborgium.
Seaborgium. Very good. Seaborgium.
SG. SG symbol.
Seaborgium. What is the symbol? SZ.
SG.
Good. 107.
Borium.
Good. Borium. Borium. Symbol BH.
BH.
108.
Hassium.
Very good. Hassium. Symbol HES.
HS.
109.
Meitnerium.
Very good. MEI. Meitnerium. The symbol MT. 110, 110.
Dermastadium.
Derm stadium series. Derm stadium symbol DS.
DS.
Okay, then Rontisium. Rontisium.
RT.
So here Rontizinium symbol, what we can say, RZ. Okay, after that 112, that is called Copernicium.
Sir, sir, 111 का symbol RT है ना?
or RZ.
T.
No, RZ होना. Rontizinium. RZ. Here G आते रोंट तक है RONT GENIM RZ symbol. RZ लो.
Okay, sir.
Copernicium. Copernicium symbol CM. Bas. These are enough. Up to now we know correctly these are only. Okay. Just here important, first four important. So Mendelium 101, Mendelium 102, Lawrencium 103, Rutherfordium 104. These are the important. Okay, we know these IUPAC symbols names very easy. If you know this line, okay, nil 1, un 2, bi 2, tri 3, quad 4. Pent 5, hex 6, 7, sept 8, oct 9, and so based on that we will give the names. Okay, finally name we are adding common IUM. Symbol is very easy. We can say immediately symbol. This is the IUPAC nomenclature for elements having more than 100 atomic numbers. More than 100 atomic numbers. Okay. Now, what is the symbol for what would be IUPAC name and symbol of the element? Atomic number 120. First, what is the IUPAC name and symbol? I'll say that. IUPAC name.
Unbiennium.
Very good.
Unbiennium.
Unbiennium. That is IUPAC name. Unbiennium. So, what is the symbol?
UNB.
Very good. Symbol un में first letter U. Okay, here 2 by B and N. UBN. Un by nil. Un 1 by 2 nil 0 120. That is a symbol. Okay, 119. Say like that. What is the name? 119 name. IUPAC name.
Uninium.
Uninium.
Uninium. That is IUPAC name.
Inium.
Symbol.
UUE.
Very
U
good.
E.
U-U-E. That is the symbol. Bas, it is enough. Now, say next. Okay, next one. Generally here, periodic table is classified as a 4 blocks. S block, P block, D block, F block. S block elements, P block elements, D block elements, F block elements. That is classification based on electronic configuration and differentiating electron. Now, first of all, what is called differentiating electron? Okay, here differentiating electron means which electron entered in an orbital of an atom lost. That is called differentiating electron. Lost electron, that is a differentiating electron. For example, I have taken potassium. Okay, say its atomic number 19, atomic number. Okay, what about its electronic configuration? What about potassium electronic configuration?
4s1.
1s2, 2s2, 2p6, followed by
2p6,
then
3,
very good 3s2, 3p6.
3p6,
Okay, total number of electrons here, if we will count 6 plus 4, 10, 10 plus 2, 12, 12 plus 6, 18. One more electron is there. Next orbital.
4s1.
Very
4
good.
is 1.
4s1. See, this is the correct electronic configuration of potassium. See, here the last electron, this is the last electron here entered into S subshell. 4s. What are the S? S subshell. S orbital. So this element belongs to S block element. This electron is called differentiating electron. The last electron, that is called differentiating electron. Differentiating electron, last electron. Here the last electron entered into S subshell. So the element belongs to F block, S block. So what is called differentiating electron? Last electron. If the last electron entered into S subshell, that belongs to F block. If that is entered into P subshell, that belongs to P block. If that is entered into D subshell, that belongs to D block.
D block.
If entered into F subshell, that belongs to F block. Okay, if I have given, okay, one more fluorine. Say that. What about fluorine atomic number?
9.
9.
9. Say what about its electronic configuration?
1s1, 1s2,
1s2.
2s2, 2p5.
Very good. 2s2, 2p5. Total number of electrons are 9 according to rules.
9.
First, the electrons are filled lowest energy orbital, lowest energy to highest energy, increasing order. So 1s2, 2s2, 2p5. Okay, now here the last electron, see this. The last
P block.
electron entered into which subshell? P subshell.
P.
So the fluorine belongs to P block
P block.
element. The fluorine belongs to P block element. Okay. Now I have taken scandium. Its atomic number 21. Scandium atomic number. Okay, say what about its electronic configuration?
1s2, 2s2, 2p6, 3s2, 2p,
1s2
3p6,
good,
4s,
2s2, 2p6, 3s2, next
3p6,
good,
3p6, 4s2,
3p6,
4s2,
next
4s2,
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 3d1.
very
3d1.
good, 3d1. Okay, according to rule, the scandium, it contains 21 electrons. Based on rules, here filled 21 electrons like this order. Okay, here the last electron. This is the last electron. See this.
D block.
The last
subshell.
electron entered into D subshell. The last electron entered into D subshell. D subshell. So the scandium belongs to D
D
block element. The scandium belongs to D block element. Like that, any electronic configuration, any element is given. Any element. We can say the element belongs to which block? Based on differentiating electron, last electron. If the differentiating electron, that is nothing but last electron, that is entered into S subshell, the element belongs to S block. If P subshell, the element belongs to P block. If D subshell, the element belongs to D block. If F subshell, the element belongs to F block, and so on. This is the classification of elements based on differentiating electron. There is nothing but based on electronic configuration. Right? Here, any doubts?
No, sir.
Okay, it is clear concept.
Yes, sir.
Yes, sir.